the section 9.2 video lecture on confidence intervals for a population mean. So what we're going to do today is going to be pretty similar to what we did in section 9.1, but with the twist that we're going to do it for means. So we're going to have to talk about some new stuff. The first of these new things is the student Tease distribution. So when we were doing this for proportions, we were able to use the normal distribution because we knew what sigma was. We could calculate sigma. But when you're dealing with sample data for means, you're going to be using the mean and the standard deviation from the sample. So we don't know what sigma is. So we have to use a new distribution called the student Tease distribution. So suppose that a simple random sample of size n is taken from a population. If the population from which the sample is drawn follows a normal distribution, the distribution of t equals x bar minus mu over s divided by the square root of n follows the student t distribution with n equal n minus 1 degrees of freedom, where x bar is the sample mean and s is the sample standard deviation. Now what you should notice here is this looks a lot like what we did for z-scores, except instead of using sigma, we're using s. And when we use s, we get a slightly larger standard deviation than we did when we calculate sigma. So that's why we need to use this t, and it's going to be a little wider than it would be if we use the normal distribution. So the t distribution is different for different degrees of freedom. So the more degrees of freedom you have, the closer this is going to look to the normal curve. And if you look down here at the picture at the bottom, notice we've got the bottom curve with the orange highlighting green is with n equals 5, and then pink is with n equals 15, and then the blue curve is a normal curve. So as n increases, as the degrees of freedom go up, the graph gets closer and closer to a normal curve. The t distribution is still centered at 0 and symmetric about 0. So the area under the curve is still 1 because it's a probability distribution. So half the area is to the left of 0, half of it's to the right. As t increases without bound, the graph approaches but never equals 0, and the same in the other direction. The area in the tails of the t distribution is a little greater than the area in the tails of the standard normal distribution because we are using s as an estimate for sigma, thereby introducing further variability into the t statistic. So as I said earlier, s is a little bigger than sigma, so that means the graph's going to be a little wider, so a little more area in the tails. And as s gets really, really big, it's going to get closer and closer to sigma. So we can find these t values using our graphing calculators. So if we look at this first example, what this is saying is we've got a t distribution, so that looks a lot like a normal curve. And we want to find the t value such that the area in the right tail is 0.1. Okay, so we could give that a try. So first of all, we'd expect that to be a positive number. And the way we do this with our graphing calculator is very similar to what we did for normal distributions. We hit stat, distribution, and plot, and this time instead of the normal distribution, we're going to pick the one right next to it, the t distribution, and we're going to put in our degrees of freedom. So for this one, the degrees of freedom was 25. So I put in 25, and then it draws my normal curve. Not my normal curve, sorry, my t curve, which looks like a normal curve. Now, if I wanted to find out the probability between any two values of the t curve, I would use CDF. But in this case, I'm trying to find the t-score. So remember, when we're trying to find the t value or the z value, we're actually doing the inverse of CDF or PDF. So we want to hit stat, distribution, and then we want to do inverse CDF. And then we can put in the area to the left. Notice that if I put in just 0.1, I get a negative answer, which is not what I want, right? I expect a positive answer. So we need to remember that when we're doing these, the inverse CDF is always area to the left. So if I want to do area to the right, I can just use my complement rule. So area to the right, area to the left would be 1 minus the area to the right. So that'd be 1 minus 0.1, which gives me an answer of 1.316. So this would be 1.316. So that was t distribution. Put in the degrees of freedom 25 dot inverse CDF, and then we had to do 1 minus 0.1. So if I wanted to know area in the left tail, it's going to be a lot easier, right? I'm still going to do t distribution. I'm going to change my degrees of freedom to match my degrees of freedom in the problem, so that's 18 dot inverse CDF of 0.01, right? Because I'm doing area to the left now, so I don't have to do that 1 minus. So I'm going to use the same curve here we had, and I'm going to put in my new area of 0.01, and I'm going to go over and fix my degrees of freedom to my new degrees of freedom, which is 18. And you can see that that gives us a value of negative 2.552. So negative 2.552. Okay, and so that's the idea. And then we could also do, so this one was the t value with the area to the left. We could also do the t values that correspond to a 90% confidence. So remember, 90% confidence means there's 90% of the area in the middle, which means there's 5% on the left here and 5% on the right. So if I want to find the t values that correspond to that, I need to do t distribution of my degrees of freedom, which is 20, dot inverse CDF of 0.05, which will give me the one on the left. That'll give me this number over here. And then I also need to do the same thing for the right one, which would be 90% plus 5%, which is 95%, or 0.95. Okay, so we can go into the calculator, put in 20 for our degrees of freedom, and then we can put in 0.05, and we get negative 1.75. I mean, negative 1.725. And then we can put in 95, and we get 1.725. So this would be negative 1.725 to 1.725. And so that's the idea. So why don't you all take a moment and use your pause the video and use your ClassCalc app to try these. Okay, so now that you've given them a try, let's go through them together. So for the first one, it's t distribution with 19 degrees of freedom, dot inverse CDF, and we're doing area to the right, so that means we need to do 1 minus that area, so 1 minus 0.02. So we can go to our calculator, put in 1 minus 0.02, change our degrees of freedom to 19, and we get 2.205. So 2.205. The second one, we're doing area in the left tail, so this will be t distribution of 6 degrees of freedom, dot inverse CDF of 0.05. Now notice we did 0.05 once before, but we have different degrees of freedom. So right, we did 0.05 up here, but we had 20 degrees of freedom. So we should expect this one to be a little farther from 0 because it's going to be a little more stretched out, because remember, the smaller n is, the more stretched out the curve is. So if we go in and we put in our values here, so 6 goes in for degrees of freedom, and then 0.05, and we get negative 1.934. So negative 1.934. And like we said, we expected it to be a little farther from 0, which it is. When we had 20 degrees of freedom, it's negative 1.725, but this one is negative 1.34. And then the last one, we've got 16 degrees of freedom, and we want to find the area that the t values that correspond to the middle 95% of the data. So if 95% is in the middle, that means 5% is on the outside. Divide that by 2, and you get 2.5%. So 0.025 would go for the first one. And then to do the other side, we add 95% to that. Oops, I forgot to write the CDF. So let's go and rewrite this one. So inverse CDF of 0.025 and 0.975. So we can put those in the calculator. And I forgot the degrees of freedom, so it's 16. And so we get negative 2.1199, so that's going to be negative 2.120. And if you put the other one in, you're going to get 2.120. Okay, so that's how you can find t-values that go with the areas you want. And if we were going to do confident intervals by hand, that is something we'd have to do. Luckily for us, our calculator has the TI-83s and 84s have this built in, but so do the calculators we're going to use. So if we're using the ClassCalc app, I'll write the directions. So we're mostly going to ignore this. I mean, if you wanted to use a TI-83 or 84, you could. The directions are given right there. But if I'm going to do this with the ClassCalc app, we'll do it over here. So we're going to go to graphing. Right, first go to your graphing calculator. Then we're going to go to stat. So if we look here, we're in our graphing calculator. We hit stat. Then we're going to choose tests. And then we're going to choose t-int. So we're on the t curve and we're doing an interval. So we're going to choose tests. And then we're going to choose t-int. So t-interval. So if I choose that, it looks like this. So we've got our t-interval. And then it wants to know what is our mean, what is our standard deviation, what is our sample size, and what is our confidence level. And notice there are two options here. I can either do stats or I can do data. If you do data, you have to put in all your data values. And later, so you could use this for stuff we're going to do later, but you have to type in all the data values. I'm going to show you how to do it with ClassCalc, which I think is the easiest way to do it on your calculator because it allows you to just copy the data into the ClassCalc app. But when you have stats, this is a quick way to do it. I would use the app to do ones where you know the mean and standard deviation. So if we go back to our problem here, we're going to do t-interval, and then it's going to be our mean, our standard deviation, our sample size, and our confidence level. And so we just have to fill in those. So in this case, it says a Gallup poll of 547 adult Americans employed full or part-time conducted August 13th to the 16th, 2007, asked how much total time in minutes do you spend commuting to and from work in a typical day. Survey results indicated that 45.6 minutes was the mean and the standard deviation was 31.4 minutes. Construct and interpret a 90% confidence interval for the mean commute time of adult Americans employed full or part-time. Okay, so we just input this data. So 45.6 for the mean, 31.4 for the standard deviation, 547 for the size of the sample, and 0.9 for the confidence level. Okay, so 45.6, 31.4, 547, and 0.9. Oops, 0.9. Okay, and when we do that, it gives us a confidence interval of 43.4 to 47.8. So 43.4 to 47.8. And so what that means is we would expect the mean commute time of all adult Americans to be between 43.4 minutes to 47.8 minutes. Okay? So then the second question here says, is it possible that the mean commute time is less than 40 minutes? Well, less than 40 minutes is not an interval. So is it possible? Well, yes, it could happen. You know, pretty much anything could happen except like you could have a negative commute time in this problem. But is it likely? No. Okay. So is it possible? Yes, it's possible that mu is any positive number, but no, it is not likely because less than 40 minutes is not in our interval. Okay, so that's the idea of how these t-intervals work. So if you flip over to the next page, I've got a couple more for you. So go ahead and pause the video at this point. Try these two problems on your own. And when you're ready, you can unpause it and we'll talk about them together. Okay, So now that you've had a chance to try these, let's go ahead and go through them together. So we're going to use the T interval again. So for this first one, it's talking about the number of books that people read either all or partway through in the year 2005. So the mean was 13.4 books. The standard deviation was 16.6 books. The number of people in the sample was 1,006, and the confidence level is 99. Okay, so we can go to our calculator and put that data in. So our data once again was 13.4, 16.6, 1,006, and 99%, so 0.99. So our confidence interval is 12.05 to 14.75. So 12.05 to 14.75 books read in during the preceding year. So we would expect the average American to have read between 12 and 15 books in 2005. Then they ask you to do basically the same problem again, but now we're looking at 1978. So we're doing a T interval again. And the mean now is 18.8. The standard deviation was 19.8. They surveyed 1,006 Americans again, and we want to do a 99% confidence interval. So the only two numbers we're changing here are the standard deviation is 19.8 and the mean is 18.8. And so now we get a confidence interval of 17.19 to 20.41. Books read during the previous year. Yep. Yeah. So that's what we expect. So compare the results of the previous questions. Were Americans reading more in 1978 than in 2005? Well, do these overlap? And the answer is no. And in fact, the second interval is indeed bigger than the first interval. So we can say that most likely Americans were reading more books in 1978 because the intervals do not overlap and the interval for 1978 is higher. Okay, so that's the idea. Now, when we go in, so that's if you are given the statistics instead of the raw data. Now, if you're given the raw data in situations like this, you can also do this idea, but we're going to want to use the Statcrunch app. So let me go ahead and open that real quick. So if you were doing this for homework, okay, now that I've gotten logged in and I'm into my data sets here is all the data sets that are in our notes for Chapter 9. So I went ahead and just typed these in. When you go to do the homework, the nice thing for you is you'll be able to just copy the data into your homework. So there's a couple things to keep in mind when you're doing these data sets. The first thing is my data set large enough to use the T interval? And the thing we need to remember when we're dealing with this is that in order to assume that our mean distribution plot is normal, n has to be greater than or equal to 30. So our mean, this is something from Chapter 8, our mean probability distribution is approximately normal when x is greater than or equal to 30. So in this first example, n equals 32, so I don't have to worry about that. Okay, so great. So now we can do our t-interval. So on your, if you wanted to do this on your class calc app, first of all, what you would simply do is when you go to do the t-interval, you would choose data, and now I would just list all my data with commas. So it would be like 7, 2, 5, 4, and so on. I'm not going to go through that process because I assume all of you are doing the MyMathLab homework and therefore have access to Statcrunch. So let's look at how to do this on Statcrunch, which is a lot easier. So you've copied and pasted your data into Statcrunch using the tool in your MyMathLab homework. And now what you want to do is you want to go to Stat. And now I'm using this in a web browser, so it pops up a little differently than well in your menu. But I want to do Stat. I want to do T-Stats. I have one sample, and I have data. So now it brings up my menu. I want to select the column I'm dealing with. So I'm dealing with the first problem, so days of exercise. So I pick that column. I don't want to group them. I'm not doing a hypothesis test. I want a confidence interval. So I choose confidence interval, and then I put in my confidence level. And that's all I need to do. So now I can hit compute. And it'll tell me that my confidence interval, lower limit and upper limit, are over here. So L limit and lower limit. So mine would go from 2.19 to 3.81. So 2.19 to 3.81. So how many days per week do you participate in exercise activity? The average American would be 2.19 to 3.81 days per week. Okay, so that's all we have to do there. So that's using Statcrunch. And like I said, if you were using our class calc app, you would just put 2, 7, 2, and you'd have to type all that data into class calc, but into the t-interval function, just like we did when we had the summary statistics. So let's try another one of these together. Because if you look at the next one, it says that we can, this isn't a big enough sample size, because if we look, we have 14. So we wouldn't be able to assume that it is approximately normal. However, this one tells us that it does follow a normal distribution. Okay, so that means you can go ahead and do the Statcrunch exactly the same way. So if I go back to Statcrunch for the second one, I would go through the same steps. I'd hit Stat. I'd choose T-Stats with data. I would choose my column, which in this case is the tipping one. I would choose confidence interval, and I would put in my confidence level, and then I would just hit compute. And this one is 17.11 to 20.30. So the average customer tips between 17.1% and 20.3%.